lookalikes to quadratic equations. In this video, I'm going to be working a few more examples. So I'm going to start with example 2, which is 2x minus 9 square root of x plus 4 equals 0. I have three methods I can solve this one. I can use the factoring method, the quadratic formula, or I could use the substitution method with factoring, quadratic formula, or even completing the square. The one I'm going to be focusing on here is the factoring method. If you would like to do this one a different way, that's perfectly fine. Pause the video and try and do it on your own. I will very quickly show you the steps to the other problems as well. Alright, with my factoring method, it is a trinomial. I have three terms with no common factors, so I set up my sets of parentheses equal to 0. Whatever my middle term is, that's going to be the variable that I used here. Because if I have a root x times a root x, that gives me square root of x squared. So the square and the square root cancels out, which leaves me with my first variable of x. But I also have to worry about my numbers as well. So I need something times something to give me 2, and I only have one choice of 1 times 2. Then, factors for my last. I can use 2 times 2 to give me 4, or I know since I want something fairly large to give me my middle term of 9, I'm going to use a 1 and a 4. I'm going to pair the 4 opposite of the 2 and then the 1 here. And the reason that I did that was because my outside is going to give me a 1 times square root of x. My inside is going to give me an 8 square root of x. And I can add those together to get me my middle term of 9 times the square root of x. I want a negative 9, so both of these have to be negative. Negative here gives me my negative here and my positive there. So I have factored this completely. Now, using my principle of zero products, I have multiplication set equal to 0. So that tells me I just need to split each of these up. My first parenthesis, I have root x minus 4 equals 0. And my second parenthesis, I have 2 square root of x minus 1 equals 0. Isolating each of my square roots of x, and I do that by adding 4 in my first equation and adding 1 in my second equation. That gives me root x is equal to 4 and 2 square roots of x is equal to 1. In my second equation, I need to divide by 2 to get rid of that 2. So I have my square root of x completely isolated to give me 1/2. Now, I do have my square root of x isolated, but what we really want is x in itself completely isolated. So, to get rid of the square root, our opposite operation is to square both sides. And, of course, I should be doing it on both equations. That leads me to my final answer. X here, because my square and my square root cancels out, and 4 squared gives me 16. On my right, x here, square each part of my fraction. 1 squared gives me 1, and 2 squared gives me 4. So I have my final answers of x is equal to 16 and 1/4. Or the solution set is the same answers in the braces. If you would have liked to have done this one using the quadratic formula method, I have worked through most of the steps setting up your quadratic formula. Remember, whatever your middle variable is, that's what you're going to set your quadratic formula equal to. And we go all the way down to the very end, where we have the square root of x is equal to 4 and 1/2. Again, this is typically where we would stop in the quadratic formula. However, our x is not completely isolated, so we do that by squaring both sides. And notice this is the exact same step that we had to use in our factoring method. And it gives us the exact same answers of 16 and 1/4. So if you prefer the quadratic formula over factoring, then you are able to use that method and get the exact same answer. Now let me touch on the substitution method if you get confused by the lookalike. And if you want to solve this with an exact quadratic formula, you can use this method. The way it works is you pick a u or any other variable to substitute for that middle term. Then, if this is a perfect lookalike, when you square that variable, you should end up with your first term, which we do. So we made that substitution all the way through, and we got down to the answer that u is equal to 1/2 and u is equal to 4. However, the problem did not start in variables of u, so we have to make the substitution back. We resubstitute what that u is, and u became the square root of x. To isolate it, we square both sides. So again, substitute it back in, u equals square root of x, and you get the exact same solutions that you did before. Okay, let's look at another example. M to the 2/3 minus 2m to the 1/3 minus 8 is equal to 0. Go ahead and pause the video and see if you can work this one on your own. Now, I'm going to do this one using the quadratic formula, but if you did it using the factoring method, then I will show you those steps here in a second. Okay, so my quadratic formula. I take whatever my middle variable is, in this case that's m to the 1/3, and I set it equal to the rest of my equation. My a variable here is 1, my b variable is -2, and my c variable is -3. So I have negative times my b variable of -2 plus or minus the square root of -2 squared minus 4 times my a variable, which is 1, times my c variable, which is -8. And that is all over 2 times my a variable, which is 1. Simplifying, I get m to the 1/3 is equal to positive 2 plus or minus square root of -2 squared gives me 4. I have a negative times a negative, so that gives me plus 32 all over 2 times 1, which gives me 2. M to the 1/3 is now equal to 2 plus or minus square root of 36 over 2, which gives me m to the 1/3 is equal to 2 plus or minus 6 over 2. I'm going to split these up using the addition and subtraction. So I have m to the 1/3 is equal to 2 plus 6 over 2, which gives me 8 over 2, which simplifies to 4. So I skipped a step there. On my other one, m to the 1/3 equals to 2 minus 6 over 2. On the top, 2 minus 6 gives me a -4. And when I divide that by 2, I get a -2. So I skipped a step there as well. Okay, I have my m to the 1/3 isolated, but I want to figure out what m in itself is equivalent to. So what we need to do here is we need to figure out what will counteract that 1/3 power. And what that's going to be is taking it to the 3rd power, because 3 times 1/3 cancels out, and that leaves you with m to the 1st power. So I need to take everything to the 3rd power. On the left-hand side, 4 to the 3rd power gives me 64. On my right-hand side, again, I take everything cubed, and that gives me the answer of m is equal to -8. So my solution set is positive 64 and -8 in the braces. Now again, I solved this one using my quadratic formula method, but it would have been fine to do it using the factoring method, which I have done here. So you just set up your two parentheses. Whatever your middle variable is going to be the variable that you use, because if you took m to the 1/3 times m to the 1/3, you add those exponents, and 1/3 power plus 1/3 power gives you m to the 2/3 power, which is what we had up here. So your normal factors of 8 splits up into 2 and 4. Set each set of parentheses equal to 0. And then the same last step if we would have used the quadratic formula. We need to get rid of the 1/3, so we take that to the 3rd power. And it gives you the same solutions. M is equal to -8 and 64. If you would have liked to do this one using the substitution method, it works just the same. You use your u variable to equal the middle variable. Then, whenever you square it, it should equal the variable that you have in the front. And 1/3 squared does give you 2/3 because you multiply those exponents. So that leaves you with a exact quadratic equation. You solve it like normal, all the way down here where u equals -2 and u equals 4. But then you need to make that substitution back in. We know that u is equivalent to m to the 1/3 because of that first substitution that we made. So when we resubstituted it back in, we got the same answer. I have one more example of these. 2x minus 3 squared plus 36 times 2x minus 3 plus 35. Now my middle variable here is this 2x minus 3, because when I square it, it gives me my first variable, which is 2x minus 3 squared. Now you could solve this one by using the quadratic formula or the factoring method, but this is one where I definitely think substitution is best. So I'm going to let my u equal that yellow there, because when I square it, I get the green, 2x minus 3 squared. So now I can make those substitutions in. First, I have my green, which is u squared, plus 36 times my yellow, which is u, plus 35 equal to 0. So now I see an exact quadratic equation. So this should be pretty straightforward to solve from here. It does not matter if you would like to use the factoring method or the quadratic formula method. I'm going to use the factoring method because it's shorter. So I set up my two sets of parentheses. I have u times u to give me u squared. I have 35 and 1 to multiply to give me 35, and add to give me 36 if my signs are both positive. Set each of these equal to 0 using my principle of zero product. And then isolate my variable. Gives me u is equal to -35 and u is equal to -1. If I move both of those variables to the other side, just do opposite operations. But my problem did not start in u's, my problem started in x's. So what I need to do is I need to make that substitution back in. Okay? Instead of u, I'm going to use 2x minus 3 because that was the initial substitution that I made. So I have 2x minus 3 is equal to negative 35. And I have 2x minus 3 is equal to negative 1. Again, I just took out my u and resubstituted it back in with my 2x minus 3. From here, you just isolate your x variable. Add 3. That gives you 2x is equal to negative 32. And 2x is equal to 2. Divide by 2 to get the x's completely isolated. That gives you the answer of x is equal to negative 16. And over here, x is equal to 1, or the solution set of negative 16 and 1. If you want to double check to make sure that these work, just plug them back into your original equation and make sure that it comes up to equal 0. Now, I'm not going to show you how you would solve this one by factoring your quadratic formula, but of course it can be done if that's what you really prefer. So this video was over some examples of solving lookalikes to quadratic formulas using either the factoring method, the quadratic formula method, or the substitution method.